Hi guys, today we're going to talk about 8.4, area of composite figures. So the first thing we have is our I can statement. I can find areas of composite figures by separating them into familiar figures and solve real life problems. Let's look at our first example. So we want to find the area of this composite figure over here to the right by finding the area of the other figures or other shapes that are inside that figure. So what we're going to do first is we are going to split it into some other figures that we can see. One of the figures that I see is a rectangle. So right along here. So I see that rectangle. And then I see two trapezoids. So I know how to find the area of a rectangle. A rectangle is just base times height. And in this case, I would use 1, 2, 3 by 1, 2, 3, 4, 5, 6, 7. So I'm going to do 3 times 7, which equals 21. Then I have two trapezoids. And a trapezoid, so I'm going to label this the small trapezoid. So that would be this one over here on the left. And a large trapezoid over here on the right. But a trapezoid, you are going to use the formula base 1. So for a trapezoid, it is base 1 plus base 2 divided by 2. So you're finding the average of the two bases and multiplying it by height. So here, we are going to take base 1, which would be here, and base 2 here. Doesn't truly matter if you have this one labeled as 1 and this is 2. One of the sides is 1, one of the sides is 2. Okay, so let's erase and see what we actually have. So from here I have 1, 2, 3, 4, 5, 6. So I have 6 plus 1, 2, 3, 4 divided by 2. So I have 10 divided by 2 is 5. And then I'm going to multiply it by the height, and that is 2, how tall it stands. So that would be where I found it over here. The larger trapezoid, I'm going to do the same formula, but I will be using different numbers. So we have 1, 2, 3, 4, 5, 6, 7. So again, we have base 1 plus base 2. So I have 7 plus 1, 2, 3, 4 divided by 2 because I want to find the average. And then I'm going to multiply it by its height, 1, 2, 3. So over here for the small trapezoid, I guess we should figure that one out. We said 6 plus 4 is 10. 10 divided by 2 is 5. 5 times 2 is 10. So we have 10 units there. Back to the larger trapezoid, we have 7 plus 4 divided by 2 times 3. So we had 5.5 over here on the left times 3. That's going to give us 16.5. So I'm going to add all three of those values together. So we have 10 plus 21 plus 16.5. And that is going to give me 47.5 units. And this time we are looking at area. So we have to square our units. Before we were looking at perimeter, we were just going around the outside. This time we actually need to have units squared. Okay, go ahead and pause the video and try the next two on your own. All right, let's look at example 2. We are finding an area. So we want to find the area of the portion of the basketball court shown. So we see that we have a rectangle and then a half circle. So we would have a half circle and then our rectangle to actually find the area of the entire thing. So the rectangle is again base times height. So that would be 19 times 12. 19 times 12 is going to give us 228 feet squared. The half circle, or semicircle, is going to be, the area formula for a circle is radius squared. times pi. And then because it's half, we're going to divide by 2. So my radius, over here I have, here is the diameter. That would be our diameter. So that's 12. So diameter equals 12. So that means radius is half. We get 6. So I'm going to have 6 squared times pi divided by 2. 6 squared times pi is 113.04 divided by 2. That gives me 56.52 feet squared. So for my total area of the entire thing, I need to add them together. So I need to take the 228 plus the 52. Add them together, and I should get 284.52 feet squared. Again, we're looking at area of the composite figure. Okay, let's look at our example 3. We need to find the area of this figure to the right. So we have 3 different figures, 3 different shapes within this figure. We have the area of a triangle, or we have a triangle, we have a rectangle, and then we have a parallelogram down here at the bottom. The area of the triangle. So the area formula for a triangle is base times height divided by 2. Area formula for a rectangle, we can say base times height. Sometimes we may look at that as length times width. Either are fine. And the area of a parallelogram is the same as a rectangle. So we would just take length times width or use base times height. All right, so let's take a look at solving for our triangle. Our triangle is here. We have our base as 11.2 and our height as 4.5. So I'm going to do 11.2 times 4.5 divided by 2. So the area of the triangle is 25.2 centimeters. And again, it's squared because it is area. The area of the rectangle is, we have 4.5 by 8. So we have 4.5 times 8. And that is going to equal 36 centimeters squared. And then the area of the parallelogram, we have the height. And then, well, I guess we can use the one on the bottom. So we have our height and our base. So if we use our base and our height, we're going to do 6.7 times 8. And that is going to give me 53.6. And again, centimeters squared. We're going to add all 3 of those values together. So we take the 25.2, the 36, and the 53.6, and add them all together. And we get 114.8 centimeters squared. Okay, go ahead and pause the video, and you have 2 more. Try on your own.